Böck. He is currently the head of research at Genie Enterprise, which he'll tell you a little bit about that in a minute here. He has a PhD, and there's a bunch of wonderful German institution names here that I'm not going to say very well, and I apologize for that. But this is from the Otto von Guericke University in Magdeburg, Germany. Did I do okay?
Yeah, I will pronounce it.
Okay, he'll correct me in a minute. He's worked on various multidisciplinary initiatives over the years, and that's part of the reason how we got connected. We actually met the first time in person in Lisbon at an Interdisciplinary Network for Group Researchers conference, where I was like a social scientist interested in groups, and he's a computer scientist also interested in groups, and we had a neat conversation, and that led to our collaboration. His research focuses on automatic multi-party investigations, group assessments, and natural language understanding. Of interest maybe to this audience would be his work in human-computer interaction, and he's been a guest editor on multiple books and journal issues. He has 80 peer-reviewed publications as well as a book, so he's very well established in the field and doing some really cool things. So join me in welcoming Dr. Ronald Böck.
Yeah, thank you for being here and being invited to this lecture series. I hope this works fine and you can hear everything. Yeah. Okay. Also, welcome to the guys being around in Zoom. So this lecture is, and yeah, thank you for that introduction, Joe. And he already mentioned that I'm now recently with Genie Enterprises, being the head of research over there. And yeah, so the talk, this way. The talk for today, let's try to do that. You now may see the full title, is Automatic Analysis of Multimodal Multi-Agent Interactions. And I will explain in a few minutes what does it mean, or what's my understanding at least of that term. And to be honest, I'm considering myself not being the expert. So there are a lot of people being around doing a lot of things. So these are my 2 cents on that issue and on that topic, and it's my perspective. So I was over 15 years with the University of Magdeburg, or Otto von Guericke Universität, Magdeburg. The name is, he's the guy who did a lot of work in pressure and vacuum, so he might be famous for it. And here you see the list of projects and also the fundings, mainly related to the German government and EU projects. So, and what is my, or where we are at the moment? So, Genie Enterprises is a company, the headquarters is in Wilmington, are in Wilmington, Delaware, but to be honest, I'm in the branch office Germany, which is located in Ludwigshafen. Really nice view, almost nice view to the river of Rhine. And I'm currently staying in Magdeburg, which is close to Berlin. And Munich is over here, Cologne is over here. And I don't know why, now I know why. For any reasons, Heidelberg is over here. I was asked why you are still always asking for Heidelberg, especially so in Tennessee or Memphis area. Yeah, of course the reason is Elvis Presley was there for military. And yeah, and by the way, the capital is not Heidelberg, it's Berlin. Also a funny question I was asked, I don't know, 100 times, being around Memphis. So, just for kidding. And my team is here, so they are doing really good jobs in sentiment analysis, text analysis, and machine learning. And by the way, this is the CTO of Genie Enterprises. So, just a rough idea on where we are and what we are doing. So the talks today is mainly interested in machine interaction. So we're interacting with machines. So we interact with this machine here, or your computers, or with such devices, or with robots, or whatever you like. And this is the challenge in this situation. So you have multiple instances of technical devices. You're trying to get a bit more intelligent. And this is what we usually do. So give me a few moments to introduce what we understand of, or I understand of an interaction. So it's a use of naturalistic patterns, whatever patterns will mean, we see it. So there are multiple patterns around. So you're nodding several times. It's a pattern. I'm staying here and gesturing. It's a pattern. I'm speaking. It's also a pattern. And we use multiple modalities. Again, video, audio, biophysiological measurements. But given this understanding of an interaction, we see that there is an evolvement over time. And starting in the beginning, we see here Babbage Analytical Engine, which is a technical device. In pure sense, it's really technic. There are wheels, there's something that really moves. But we see then there is an involvement, and we see here one of the first computers being around in 1941. And then there is a time, you see here, and the time ranges shrinks more and more, and we have here our now interacting devices. Here the interaction was mainly by cards. You have these cards, and you have to lay it there, and then it's doing some magic, and you get out a card which you can't read immediately, but you have to translate again. But then we come up with these interaction devices. So like the mouse or the PC itself with a keyboard. And I found it quite interesting that already in 1983 we had touch screens available, which is okay-ish. You see it here, there is a glass over there you can press on. It's not that touch screen you use here, but it is there already. And then we have further developments. We're going from pure text to graphic interfaces, like the famous Windows here. And then it evolves more and more, and the level of interaction increases over time. What happened in the last, let's say, 30 years? There is a lot of things, and we can say that we go from just an interaction towards a more anticipatory, intelligent interaction. For me, anticipation means that we had an adapted reaction of the system and a kind of a guess of users' action and reactions. I say guess because I won't claim that we have the final and absolute knowledge about what is the user thinking. We just see something and we try to establish an understanding what is the internal representation of what I'm doing. So my common example is, in this sense, you probably think I'm okay, I'm not nervous, but I can tell you I'm a bit nervous. And crossing fingers, you can't hear it. So you would say, oh, everything is fine, and I'm still having a heartbeat and rate whatever, 100 and above. So, and that's why I say we just see an external view as computer scientists. And we have to guess what is going on. And given this in mind, we see developments like the first smartphone, they called it also companion. It's the IBM Simon, back 1994. Then we have the multiple devices like these mobile navigation devices, and finally we have a breakthrough. It's for us the iPhone. It has these small touch screens. It has a kind of an adaptation in the way you interact with the machine, saying that you can rearrange automatically the GUI, for instance, so the graphical user interface. And then what we see today is, today means in the last 2, 3, 4 years, we have an increase in smartwatches. I'm an old-fashioned guy. I don't have one. And I have also an old-fashioned notebook. But we see also a human-machine interaction which is now starting to be more collaborative. You usually know if you want to work with with a robot, for instance, it has to be in a fence and in a cave, and there is some restrictions. Now we start having a real collaboration with the robot. And what we are looking for is something like this. And here we see what a multi-party interaction would mean. We have humans, we have robots, we have virtual agents, we have multiple systems being around. And yeah, from a group's perspective, this could be a group, but we can extend it immediately to multiple humans, multiple robots, multiple virtual agents, as you will see in the talk. And we see here that we need an increase in the level of anticipation. Here, the mobile navigation device, it's something okay. If it's, it takes me, or it suggests me a route and then that's it. But for a robot being on the desk, it needs a kind of an interpretation of what I'm trying to do. These robots is fine, but you see these large robots that can lift the whole car, for instance, and doing this, I won't be there in the way. And I won't be afterwards. So the question is, how can we achieve this level of anticipation and individualization in today's systems? And for this, just to give a short idea, here we see the multiple goal functions and the intelligent individualization part. So, for instance, such a cleaning robot, it has one functionality, it should vacuum, and almost no individualization. The mobile navigation device has also just one purpose, but it should be somehow adapted. So I'm going this way, I usually prefer that route, and so on. So then we see smartwatches. They are somehow in between. We have multiple functions, we have a kind of an adaptation, and then we see here again as an example, smartphones, a lot of functionalities. You can probably use it for calling, but mainly you use it for almost everything. And it's highly personalized. Yes, okay. I guess everybody knows. And here, for the technicians, it's a blade center. Multiple instances, no individualization. It's just running algorithms and doing it fast and efficient. So But still the question, how we could achieve this? And there's a good interpretation of, for instance, Frank O. He's from the Leibniz Institute doing a lot of experiments on dialogues in animals. So how they kind of communicate. And now we transfer this to techniques. So it says reactions and anticipation. So you see each system generates on a reaction in the user. So, and this could appear on various instances like gestures, facial expressions, the way how I speak or the user is speaking. And perhaps it shows affects. So being confused, for instance, with Windows, once again. And then we should anticipate as a system. We try to get the effects and intentions of the user to react properly. And this is a part of my talk, is considering these aspects here, and that's why I just want to talk about these 4 aspects in my research. So it says selected contribution to research directions. I did a lot of things, but here I focus on these 4. And it's mainly about interacting and attention. So it's also related to social sciences. And I was asked by Joe to neglect most of the computer science stuff I would really love to talk about, but I try to focus it a bit more to social sciences and health care sciences, health sciences. So that's one reason. Another one is how we could consider these patterns. Here in particular, movement patterns I selected. And also speech and acoustics. And here I'm trying to bore Joe, because we did the work together. And finally, how we could come up with the behavior of these technical systems. In my group, we call them true artificial peers. And there's a recent paper, recent means it appeared 1 month ago, on that behavior generation. So, and there will be a lot of perspectives in the outlook. So let's start with the analysis part. Multimodal, multi-agent interaction. Why should we consider it? I already tried to give a motivation for it. And for me, speech is a quite important part or modality to transfer information during a communication. You can use a lot of variation in your voice. You can speak calm, just to get everybody's attention. Or you immediately raise the voice to wake up everybody. So you see, it's a way you can communicate without communication. So what we often do is we just look at the acoustics, not on the content, just on the acoustics, and you immediately get something. I can do the same thing, just saying blah 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 blah, and you mean immediately. Now this was the point. So, by the way, this is how it looks like for the algorithms. They are stupid. They don't know what I'm really talking about. So it's mainly blah 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 for them. So, and now we want to have a transition from a dyadic interaction to a multi-party interaction, and finally come up with the goal I already described. I won't bore you about the multiple things done in the interactions. If you like, I can come back later and explain every paper here. But there is a lot of things done in the communication sciences we borrow and lean on. But there is also a lot of work already done in various perspectives on body movement, speech analysis, and how to classify it, how to get some ideas from it. And then now let's go to some real results. For this, I consider at first a corpus. So just to get an idea what we are doing. So we are mainly working on recorded data. We can do that online, but this is for test purposes mainly. So we use corpora. And one of these corpus is the Cassia Coffee House corpus, which looks, this is a screenshot over there. It's a scenario in a coffee house. That's why it's called Coffee House Corpus. And it was recorded at the Chinese Academy of Sciences Artificial Intelligence Institute. That's why it's called Cassia.
Ronald, real quick.
Yeah.
Corpus, data set. Corpora, data sets.
Okay, yeah, sorry.
Just a different terminology for the same kind of thing. So the coffee house corpus is the coffee house data set. That's the data set that Ronald is working with in this particular paper.
Yeah, sometimes we also use data sets just for a variation of writing, but we use mainly corpus as the term. So, okay. Now it's clear. Okay.
No, you're good. That's one term that always threw me initially when we started collaborating.
Okay, yeah. I wasn't aware of. So,
yep.
Okay, thanks for clarification. So here, two virtual agents, and the colleagues in China called this guy the boss. He's the owner of the coffee house, and this is the beautiful girl. It's melodic, and we call it girl for short. She's another customer, or pretend to be a customer, and then we have the human here as the real customer. We recorded 50 participants, and it ends up with roughly 12.5 hours of multimodal data. You can't see it properly, but here is a Kinect sensor, and there are microphones, and she's wearing also a headset, and all the conversation is, we call it free conversation. That means there is no limitation what to say. You can do whatever you want, you can say whatever you want. You can also behave in a way you want. By the way, this is a mixture of Wizard of Oz scenario. Is it is a term you know? Wizard of Oz scenario? Who's knowing it?
I know the Wizard of Oz, but...
Okay, 4. Then I explain it, and you are now out. You are not anymore allowed to do that as participants. You have a kind of a mock-up. And in the background, you have operators being the boss and being the girl. So you can do something there. You can get mock-ups, and you can do your experiments even if the technology is not ready yet. But if you know that, it's not that fun anymore, and that's why we can't tell the participants that this is a mock-up, because then it's not working anymore. They have to believe that these are real agents, and in that sense, it was a mixture. So there was an automatic speech processing, but the domain was selected by the operator. So if the person switches from, I want to have a coffee, to, oh, what's the weather outside, they can switch it. So this allows more freedom in the interaction. And what does we investigate, or here I'm just presenting 2 aspects, namely the interaction patterns in the way of purchasing behavior, and movement patterns during that communication of that 3 agents here. First of all, let's consider the dialogue interaction and the way they this fits to the scenario. And that's why we compare here the head movement and the dialogue flow. You will see now a graph, and this is just to explain it a bit. Here we have the dialogue flow. So every turn the person is speaking was a bit compressed here, so it's not the full reaction, it's an excerpt here, so there was interaction going on before and after it, but it's the most interesting thing, part here. So we have an interaction in terms from the participant, from the boss, and from the girl. And what we did is, now I have to move a bit, so we have, should I do it? Okay, I can do it this way. So here is the boss, here is the girl on the walls, and I was talking to the boss, blah, 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 or the participant is talking, and then the girl approaches and saying, hey, hello, how are you? Are you queuing? Blah, blah, and trying to get the attraction. And this is what happened here, and so the girl attracts attention of the person, so that's why you see here these dialogue terms. And in the beginning there was something, yeah, hello. And after talking and still talking, the person turns over. This was a successful transition for us. Now we know, oh yeah, the interaction changed. In contrast, here we have almost the same situation. The boss is talking, the participant is talking, the girl is also trying to approach the person, but after these initial things like hello, how are you, the boss asks, do you want something else? And the transition was broken down. It took then again a while to get the attraction back. And this was something we figured out was somehow surprisingly for us. Okay, why is this happen and why do we really want this? But we also had a cross-literature research in terms of social science. And we found, and please don't want me to pronounce the names, that an almost equal behavior could be seen in purchasing situations of humans. This was really surprising, a real surprise for us, that they showed the same behavior while interacting with virtual agents. So for us, it was given, and I have all the time to say, given this data, that there is a quite same interaction pattern in purchasing situations of virtual agents and just human groups. This was quite interesting for us. So, yeah, so this is the first take-home message here. We see that even in these purely technical situations, we can find patterns which are already seen in human interactions. And you can compare this, it was published here in 2013, it was seen in 2016 to 18 and published in 2020. So this is the first thing we check. And then we also saw that the context is a matter here. Again, in our situation, the context is important. So they don't know each other. They are somehow familiar. They have the same intention. He's trying to sell coffee. She wants coffee. And so the context and the situation where some interaction is going on really matters. And we have a paper on that how we could model these contexts and how we could use this as an additional source of information for the technical systems to interpret the ongoing interaction in a more advanced way. So, and keeping this picture here in mind, we will see that this interaction setting also influences our movement patterns, which is also something I was surprised of, because given the setting in the coffee house corpus, so we have here real furnitures like stools, chairs, and like tables, and then we have the bar or barista equipment over here, and this is the sender's setting, and we have the two agents here. The person, again, is able to do whatever they want. Even they could sit there and just talk to the guys. No, they don't. It's like in a real purchasing situation. And so we define a movement pattern as a prototypical, interestingly and hopefully longer lasting behavior of a participant in a certain scenario. Could be either the full body, like I did now, or if I'm sitting, it's the upper body movement. And so from this we can come up with a question, are there prototypical movement patterns? Or from these anticipations perspective, the question is more, can behavior patterns being derived, which are informative for us to in such a situation? And yes, we can. This is the good news here, and this is published together with colleagues from the Chinese Academy, and we find prototypical patterns. We expected a number of it, 5, 6. Interestingly, given a bit of a variation, we found 2. Yeah, a band behavior. These are names from 2016, and currently I stick with it because it's published, but it's something I'm not really happy anymore with. But this is what we see. We saw a kind of a band behavior moving with 2 attractions. What does it mean? Again, here's our boss, here is the girl, and what the person is doing, they are moving on that, a kind of a road. That's why we called it band. So using all the time the same way, back and forth. And here we see that there is an attractor close to the boss and close to the girl. Boss, girl. So you see it's almost on the same range. And the second one is a more, and we call it chaotic, now I would call it exploratory. So they try to explore the room while they interact with the persons. And you see, I'm more the exploratory or chaotic guy. I'm doing the same here. So while talking, I walk the room, not using, yes, I have an attractor this here, because here's the slide. But I'm exploring a bit. And it's not related anymore to the positions of the 2 agents. And we can classify this automatically. And as I said, I won't bore you with a lot of technical things, but we find a way to use this data. Here we have how many measurements? 150,000 measures per interaction. So it's not ideal to use this directly, because you have a lot of redundancy in it. But here is a way we can do that. So we model it as Gaussian mixtures and then come up with some parameters from that mixture model here and use this for classification. And given that and small number of artificial neurons in a neural network, we can classify that with roughly or 87% average accuracy. Accuracy means all positive votes divided by all possible votes. And yeah, this is one result. So we could first of all find this pattern, and secondly also classify this with with a simple network. There's no deep learning necessary in this sense. My question was then, coming back from China and look into the corpus we recorded in Magdeburg, are there also these patterns? And what is the difference there? We have just a dyadic interaction of one human and a technical device. So the person here is planning a trip, and you see here all the modalities. And as I said already, we have cameras, we have microphones, we have headsets, and we have biophysiological data here. And my question was, could we find these patterns also, or some identical patterns, or even more patterns in that dyadic interaction? And I expected to see different patterns. So now you already know the answer. We see almost the same. And again, the person here is allowed to interact freely, so can say whatever they like. And the most interesting thing, and this is the difference to the Cassia corpus, we have also questionnaires of socio-psychometric parameters available. And then we did the same investigations and come up with the same prototypes. Again, and that's why I stick with names, the band behavior. So the person is sitting and doing something like this. Just, or these exploratory or chaotic, so, oh my God, oh no, oh, what should I do? Something like this. And if you watch the videos, it's really this. Oh my God. Because the computer did some things. Later, after the talk, I can give you some insights on that data and provide you with more details, but otherwise I run out of time. But I see it's still 10 to 1. So if we sit here in the evening, it's fine, it's still 10 to 1. So the message here is, it's a totally different interaction, but we see the similar behavior. It was surprisingly for me. I don't know. And then this is luckily we can also see the same way of classification, just a simple network and almost similar classification rate. Why here the average is a bit lower, you should keep in mind, here I walked a room while sitting at something like this. So the differences in the measures are higher. The variance is smaller, and so we have to be aware of that. And then we compared it to socio-psychometric parameters, and we see on annotation level almost no significant correlations. But looking onto feature levels, so what is the position the person take? It's like being leaned towards and then doing that, or really straight. There we saw some observations and correlations, especially to age and sex. And it's still under investigation of the colleagues in the social science and psychology department why this is happening. So they come up with ideas about that. So this is the movement pattern part, and combine that as take-home messages. We see that we can observe similar behavior as in human-human purchasing situation. We can find prototypical patterns and classify them, and we see that there is also some significant correlation on feature level here. So this was the first part. But how could combine it in the daily activities? We can do that using the Mobile 3D project, where I was part of, and this is how we can apply that. And the idea, and sorry for the German-centered way, but it was a German project, yeah. So we expect in 2050, almost 27 million people being older than 65 years in Germany, which is roughly 1/3 of the population, just to give an idea. So, and therefore we lack of personnel to take care of, so nursing and so on. And there are some risks, high risk of fall or emergency or daily activities like drinking. They forget about it at some point. And so the solution is more related here in that project to ambient assisted living. So having technology assisting the persons over there to stay in their flats. And we tried, or not only tried, we did it already, is sensor development with on-site data analysis. It's really important to say, or to highlight, on-site data analysis. So I don't know about this here in America, but Germans are quite afraid if you say, oh, by the way, I sent you the video data somewhere, it's analyzed, and then you get a feedback. It's something like, oh my God, no, I won't do it. So that's why it's on-site. I just usually kidding and saying it's as secure as you have somebody here, because it has to plug in an LNA cable to the sensor. So if you let the person in, it's not secure anymore. So, and for this we did a lot of work. It was a collaborative project together with folks over in Chemnitz. They did the vision part. So the details I would avoid here. It's it's a 3D measurement of the room and also a 3D ocular measuring of the behavior, the patterns in that room. And we did the speech analysis. So if we, for instance, the person falls down here and there is the sensor, you can't see the person, but you can hear it. And so we combined this in a multi-sensor and multimodal setting, and finally we have also prototypes. So how it looked like, sorry, it's like this. So, oh, it's a bit shifted, there should be the text still there. Anyway, we see here that this is, sorry, it's the sensor. We have a light integrated, so you can immediately plug it to the ceiling and get rid of your common light. So you have it here. And it looks a bit high. It's roughly this height. But it's a matter of on-site computation. So there are a lot of small machines in, Raspberry Pis, Arduinos, and so on. And we have here also an interaction. So there is a text-to-speech, so the system can talk to the person in the room, or the user in the room, but also interacts via light. So blue means I'm active, red means I'm not active, and then in a case of an emergency, it's having these bulb light. Meow, meow, meow. And immediately calls the relatives and the emergency. So this is the prototype here, and yes, you can use it also for other purposes. We mainly opt for health applications, but you can do it also in the production or security, or even in mobility. So if there is in public transport an issue going on, you can figure it out. Yes, so this is something to link the research to applications, also a bit related to the health situation some of you working in. So, and analyzing speech is a second perspective I want to share with you. And here you see it already, and I gave interpretations on it, so I will keep it short here. You can either scream to the machine, but the machine says, I don't care. Or you whisper to your the final knowledge of the universe to your neighbor. And yeah, so there is these differences. And now it's ideally Joe's part to give the introduction, not me. But there is a lot of work meetings going on, and also business meetings being effective or sometimes not. And the question is, could we find patterns or acoustic patterns already for these meetings to be somehow classified as effective, non-effective, or something else? And yeah, so the question is, what is the sound of a fruitful meeting? This was the title of the paper. And there's also a lot of research going on. You are the experts here. It's just something I read and recapped, so I will avoid it. And there's also a lot of work going on in technical analysis of language, of acoustics, of prosodics. And so just acoustics means everything. So each sound from me, I produce or you produce is acoustic. Prosodic means the levels and the non-spoken analyses of these acoustics. So just to clarify the terms. And yeah, we considered here the groups, and the idea was, what is the sound of the meeting, and what does it tell us about the meeting success? And the second question is, do we find clusters in these meetings to appear meaningful for this effectiveness? And do we find also indications that longer lasting meetings are less effective? This is something I would say is the common understanding. So the longer the meeting, the less effective. And for this we used the parking lot corpus. It's a corpus with 70 meeting groups, in total 245 persons recorded. It's again a free interaction on a topic, on a particular topic, namely the parking situation at that university. That's why it's called parking lot corpus. And we considered subjective performance measures, mainly the overall meeting effectiveness and the satisfaction with this meeting process, and the object performance measures, namely the total recommendations they come up and if they are feasible or not. So this is, these annotation was mainly done in, or was done in Joe's group. So, and the analysis is a collaboration of Oliver Niebuhr and myself, and we all collaborated on that work. And here we used Praat. It's a quite popular toolkit for prosodic analyses in our field. And this is done on interparsal unions. It's a bit technical description of everything what is spoken. So we distinguish between acoustic material and pauses. Pauses is that, and spoken is that. And so we come up with roughly these numbers here. You see there's a wide range of IPUs during that meetings, and here you see features. Features means some measurements extracted from the raw material. So it's like a meta understanding of the raw material. And here we see pitch or duration variations and several functionals from it, on it. And here it looks how it looks like in the way of Praat outputs. So first of all, let's see the sound of the meeting. And we found here, and credits to Oliver Niebuhr, I took some of the slides from him for that. We found that, yes, there is a relation between the effectiveness of the meeting and the duration. And you see here, there is a decreasing trend. So we would say, yes, it somehow proves the common understanding. The longer the meeting, the less effective. But being aware that here the range of the rating is one scale. So in this sense, we also considered several influences here from the variance of the intensity level. So is there a person just speaking like that, here is my information, I give you the information, or is there a lively discussion? So variations in my pitch, for instance. This is what I'm trying to do here as well. And yes, you see here that there are positive trends, especially also for the effectiveness as well as the number of recommendations. So here I won't read the take-home messages, you can do that, but the main interpretation is we saw that there is somehow that common proof, but it's not that an issue, and we see that the more varying the meeting sounds, the more effective it is. And this is a similar interpretation here. You see for that plot the least effective measurements, so the least effective meetings are set to 1, and the more effective have these variations. So a smaller pitch maximum, pitch range, and so on. So I won't read all numbers here. And the same is also given here for the number of high recommendations, and here it is the mean effectiveness. You see the range, especially here, for the pitch is quite important for the number of recommendations. So, yes, we saw that, and now we were a bit upset. It sounds like it's mainly mean features of pitch and the skewness or the variance which matters, but what is about the real interpretation of this effectiveness? And now I come back to that slide here. We saw that it's just a level of 1 here, the difference. So it's not that huge in the annotation. So that's why we analyzed also times versus effectiveness. So what does it mean? So the total time of the acoustic is the accumulated time of verbal and non-verbal expressions. So everything like, or I really convey and transmit information. Taken together and compared for the group leader and the remaining group. And the number of turns is everything I said. So each turn 1, oh yes, turn 2, and so on, accumulating it. And having this in mind, we started again the analysis of the parking lot corpus, but now distinguish here group leader and remaining group members, and found some clusters. And interestingly, the informative clusters here are for the leader and the remaining group, that the timing, so it's in seconds, 800 seconds here, and the effectiveness. Yes, time is indicative or discriminative for the future meetings, and the same for the groups here. But it's, again, there is an indicator. If I just say here, having a boundary here and here, we see, yes, the majority of the meetings are here, being quite short, but there are some of these longer meetings, and especially they will be rated really, really high and effective for the remaining group, not only from the leader, but from the remaining group. And this was something we were surprised of. So on the one hand, it looks like the common understanding is, again, being proved, but there is this additional thingy there. And also, considering the number of turns, we see here that the effectiveness is not dropping drastically for longer meetings or longer number of high number of turns. And for this, we see that longer lasting meetings show even high effectiveness, or and the high variation in short and few numbers is given, so there's no clear indication anymore. This is the outcome from that, and that's why we ask, is there some clusters being shared between the groups? So do they consider the same meeting being effective? And yes, we see, but it's still somehow confusing, especially for the medium and many we have here. So given that data, and again, given the parking lot corpus, there is a way something we argue on, namely a stimulating meeting. Stimulating in this sense means that there is here you can read it, I just paraphrase it, is we have...
Okay. Right. Someone on Zoom was talking, I just muted them, so...
Oh, sorry, okay. That there is an understanding, yes, we have longer lasting meetings, but they are being experienced to be familiar, to be effective, and this is, from our perspective, a kind of a bet for a better performance later on. Because in the meeting corpus we analyzed, there was no familiarization going on. So they don't know each other, and that's why they felt effective or efficient to get a familiar situation for later conversations. So as a kind of a take-home, we see more successful meetings sound different from less successful meetings. We also saw that the subjectively successful meetings sound differently. And we see that the perceived meeting effectiveness is decoupled from the particular meeting length. This is the outcome from our investigations here. And finally, now to compare this, and I will keep it really short, is what could we do from a perspective of a technical system now. We have all these analyses and how we could combine them. And for this, we ask for the behavior in technical systems. And again, there is some work already done there, especially for interfaces. And there they ask, especially Schulz and Meurer, ask already for proactive systems. And this is the way I also really like, because we need more systems not being servants, but being really peers. And here is a quick motivation. So we have these, on the one hand, dyadic interaction, but also having multiple users being in the surrounding. This is that guy here, or some that might be potential users. And then we have a lot of in-group, out-group situations going on. But for this, we need a kind of behavior. And true artificial peers, in the sense we understand it, it's a system which is a real peer, so somebody, something, which is standing alongside and having a proactive peer-like interaction, and therefore also capabilities with their own goals, own priorities, own beliefs, and own reactions. And to come up with this, there is the main idea, which is based on ACT-R systems, so it's cognitive technologies, fuzzy logic, and belief, desire, intention models, so it's more theoretical computer sciences. And the control here is that we get back from the, get away from these rule-based systems we usually see, using an exploratory part, and then come up with a data-based, so a personalized understanding of that interaction. If you are really interested in all the math and the way it works, read the paper which is out, and read the patent which will be out on that. But the main and rough idea is that we collect a knowledge score and a user satisfaction score, which contains all these features like emotions, familiarization with the topic, current situation, and so on, to get a final behavior score B, which can then be interpreted in the way of fuzzy logic, like rule-based, exploratory, and data-based. The rule-based situation is the fallback strategy, so it works now, it should work anytime. The exploratory is trying to do something like a good friend. So an example is, oh, you really like macaroni, now try spaghetti. Oh, you don't like it? Okay, let's keep it. But just offering something. And then the database thing, the system knows that I'm in a meeting, it should turn off, for instance. So this is the behavior for short. And the take-home message is that we should have an interpretable way also of the behavior, and we can come up with that if we have these data-based situation and a system that has their very own goals and characteristics. So, and for this, I'm done with my contributions here, and just give a quick roadmap from my perspective. We should work on adaptive systems and intelligent assistance systems, multimodal analyses, and especially AI methods in intelligent interactions. And how the multimodal analyses may work, you already saw some examples. So acoustic, vision-based, or using also biosignals and the context, aiming for these assistant systems and ambient assistant living systems that use user meta information for the naturalistic interactions. Then the AI methods, there is a bunch around, and we have to figure out what is the appropriate and suitable method for this particular situation. Currently there is this immediate reaction like deep learning. We have to do deep learning. But sometimes we don't need it. I showed to you, it's a simple network which does the work. And you don't need hundreds of hours for data for training a deep network. So, and yeah, but we can then use the whole range of multi-agent interactions. And finally, these adaptive systems, and there are two dimensions which are mainly in the focus now. First of all, going out of the lab. It's something I'm talking about now for at least 7 years, but it's still an ongoing process. We are here in the safe lab, and we're developing our methods and everything, and then we should go out in the wild. And the second one is extend our foundations from single dyadic analysis over using the small groups to get to real groups with, I don't know, 20 instances or whatever. So that's, and yes, then we can use it in hybrid teams, especially. This is something pops up in Europe at the moment. So hybrid teams, it's like deep learning 7 years or 10 years ago. Now it's hybrid teams. And yes, we should consider that. That's it. These are my 2 cents, and it's still 10 to 1. Thank you very much. Hi.
I had a quick question. Thank you for your lecture. I'm trying to understand the context in which the girl is coming up. Is she interfering with the sale of coffee, or why is she interacting with me when I'm ordering coffee?
Okay. Yes, she's coming up, and oh, could I do it here? It should be. Oh no, it's too. Here. You see here, this is the, sorry, this is the entrance. So she's coming from outside, okay, and is somehow queuing. And while queuing, she's trying to get a traffic.
So I haven't ordered my coffee yet?
No, you are on the way. You're on the way ordering the coffee. Yeah. Okay. So that's why I said it's somehow controlled. So the interaction again then is automatic, but as you know, some person just walk around and then get into to order some coffee, and the timing is not fixed, and then the controller says, okay, now it's almost done, and then the girl approaches.
Thank you very much.
Yeah.
Very much.
On that scenario, if I may, have you looked at the issue of culture and also psychosocial factors? I can see where, I mean, US, I mean, we've got so much room, we just run all over the place. In Europe, people are much more constrained. China, you're really constrained by movement. So the degree of the movement, I'm just wondering if that's been looked at. Anxiety, of course, plays into it too.
Yeah, I can understand the question. So, first of all, to the second part, these social parameters, we don't. The recordings were already ongoing when I joined the group there for visiting. So they didn't consider any of these questionnaires. So I don't know if they weren't aware of. It's a pity to have don't having it. But yes, in terms of these questions, that's why I said I got back to my lab and tried to start similar experiments with the Europeans. We didn't do the exact experiment, but this is the other experiment where the person has a dyadic interaction. So, and given that data, I would say it's kind of universal here in that sense, because we see similar patterns. But yes, you are right. The Chinese culture is more restricted, yes. But interestingly, it was not that issue for that. This is how I could say it. I'm not a social scientist, so the room was not that big. It was, I don't know, mainly like this and something like this dimension. So not that that big. So perhaps this is was also a relation to these cultural, this fitting of having smaller rooms and being used on that. So it was not a real coffee bar as we would be familiar with.
Yeah, I'm getting it. The issue also, though, in Central Europe is, in my observations anyway, people don't move as much. They're much more orderly, and we are a little bit more chaotic. Canada and the U.S.
Oh, so let's repeat the experiments here. That's a good idea. Yeah, let's do that. Analyze these. So I don't know if we could see that from the parking lot corpus.
I don't know. I don't think so.
Me neither. So
maybe.
And
some of the
I
new
didn't
data
check
that we're collecting in our rooms up there, we could probably see it more easily.
Yeah.
Yeah.
By the way, I don't have the feeling that Americans or Canadians are so chaotic.
Well,
Canadians, just Americans.
Okay.
my main point of reference is near Milton Böck, which is near where my German grandparents came from.
Okay.
So not too far from me.
Okay, but nevertheless, we can try to see the data you have or you have,
Yeah.
if we find similar things in there, yeah, or different.
What I was getting with anxiety is people who have anxiety disorders are going to have a propensity towards greater movements and so forth.
Okay.
And depressive, the other side of the fence, actually.
Okay, yeah, that's here in that data we try to avoid these disease or issues in that sense.
It's 25% of the population, so good luck avoiding it.
Ah,
It
well.
ends up being an uncontrolled confounder if you don't watch out.
Yeah.
Yeah, okay.
Yep. Okay. Any other questions?
But thanks for this comment. So we should keep it in mind.
Interesting.
Yeah.
Safety side too.
That's why I really like these interdisciplinary work, because we as computer science have the data and look into the data. That's why I always said, given the data. It's not that we have a proper interpretation from social perspective or something. That's something we need from you. Okay.
Any other questions? Okay. Thank you, Ronald.
Thank you. Thank you once again for the invitation and being here.